This is Dr. Frederick. I had a question from a student about critical ranges or ranges of critical values for a z-test, and said he had entered plus and minus 1.96, but the correct answer turned out to be plus or minus 2.58. If you have any familiarity with the z-tables, then you recognize these numbers right away, that the plus or minus 1.96 will capture 95% of the z distribution, and plus or minus 2.58 will capture 99% of the z distribution. So probably the mistake was mistaking the 5% level of significance for the 1% level of significance. So the question turned out to be about the 1% level of significance. And you know, I never use tables, as I told you, but I just want to comment on something else the student said, which was that the values of 2.58 or negative 2.58 were not in his z-chart. Well, that might be true, but most z-distribution charts will go out to plus or minus 4, and it's pretty uncommon to find a z-value greater than 4 in nature. They do exist, but are so uncommon that they are generally not put in tables. Some tables just go out to plus or minus 3, but most tables should have plus or minus 2.58 to capture the 99% confidence interval. So I'm just showing you what I would do to calculate a z. I would just Google z calculator. And I always say Google. Some instructors don't like you to use Google as a verb, but I think that is just old style, not realistic. It's my favorite search engine. I don't use anything else. So I'm always looking for David M. Lane on the Z calculator, and because it gives a nice little picture here. Now there's two pictures that it will give. Well, it has changed a little bit. Oh, I see. You can make the two choices up here. So we want an area from a value. What we really want is a value from an area. And so we notice that a z distribution has a mean of 0 and a standard deviation of 1. And we want to find, we don't want to find that. We want to find the area from a value. So we want to find, we did want to find that. Okay, so let's do it again. This thing has changed. Okay, here we want the area is 0.01. We want the area to be, I'm sorry, 0.99. Okay, so when we get 0.99, the area out here, the probability of being in either of these areas is 1%. So it's 1/2% chance of being in this little white area, and 1/2% being here. A z-value outside these ranges will occur, outside this black range, will occur 1% of the time. So I'm stumbling over my words here a little bit. Let me say it differently. 99% of all z-values will fall between negative 2.58 this point and 2.58 this point. 99% of all z-values in a z-distribution in which the mean is 0 and the standard deviation 1 will fall between these values. So a z-value outside these ranges will occur 1% of the time. So when it tells you that you're going to look at a test statistic at the 1% level of significance, your question is, does it fall in the black range, in which we do not reject the null hypothesis, or does it fall in the white range, in which we do reject the null hypothesis? These values are very familiar to people who use statistics, as are plus or minus 1.96 and plus or minus 1.645. Okay, I hope that's helpful.